another thing. All right, so we're on the Precal A 1.7 notes and practice sheet. There's only 3 problems on it. Let's see how we do. First one is our box problem. So, let's see if you can remember how to set this up. Because while some of these problems are unique and different, and you have to kind of do weird stuff, not the box problem, it's always exactly the same. So our piece of paper is 12 by 9. We're going to cut these corners out right, and the size of the corner is X. Find the maximum volume of the box. Now, on your test, this is going to be a 3-part question. The first question is going to be write the equation for the volume of the box, which of course you have to do to find the maximum. You've got to have something to type into your calculator. So what's that equation going to look like? What? 12 minus 2x? 9 minus 2x times x. That's the volume of the box. Length times width times height. Okay? Now, the second question is going to be, what is the domain? Now remember, that means tell me about x. We're getting ready to graph this on our calculator, and I need to know what size my window is. So what? X is between 2 things. What is it between? 0, always 0, because doesn't x have to be positive? Yes, yes, thank you. How about the max, the biggest it can be? What's the largest it can be? 4.5. Why is the biggest it can be 4.5? Somebody explain it. Half of 9. Why am I doing half of 9? Because I'm taking a piece off each side, right? And if it's only 9, I can't take off 18 from each side or something, right? 4.5's it. That's as big as it gets. On the test, which is fresh in my mind because I wrote it yesterday, I have you write this as an interval. So what's that going to look like as an interval? Parentheses, right? Why parentheses? Because it's not or equal to? Yeah. Okay, and then in this case, the question is, find the maximum volume. So we'll go to our calculator. This is x min and x max right here. It's going to be very sad if you don't pay attention to that and you find a maximum for a part of the graph that doesn't make sense. All right, so make sure you're looking only at this part of this graph. So my window is 0 to 4.5. What's y min? Y is the volume, so y min is going to be 0, and y max is something. I'll just pick a number and see what happens. I can always change the number. Remember, you do not need to multiply out the equation. Just type it in with the parentheses. And then we'll second calc to find our maximum. Remember, when you hit maximum, you actually get a point, right? So I get the point. If I round off to the 1,000, 1.697, comma, 81.872. Anytime you use maximum or minimum, you're going to get a point. So that's, you got to stand back and make sure you're picking the right number, because one of these is going to be the answer. Since the question was, find the maximum volume, that will be our y, right? So the answer would be 81.872 square. I don't think I have a unit there, so let's say inches. Square inches. What does the 1.697 refer to? The size of the squares. So if the question had been, how big should the squares be to maximize the volume? Then the answer would be 1.697, right? Okay, either question can be asked. All right, anybody have a question about that? GTQ, absolutely guaranteed test question. All right, so here's the next one, number 2, guaranteed test question. How much of a 28% math juice mixture must be mixed with 10 liters of a 16% to end up with a 21%? So I am going to write down amount times percent, amount times percent, amount times percent. Right, now I'm going to start plugging stuff in. Almost all of that's right in the problem. So, for example, I've got 28% and 16% and 21%. That's all right in the problem, right? It also starts exactly the same way the other ones did. How much? That's what I'm looking for. X. How much 10% or 28%? Must be mixed with 10 liters. This is 10. Right? What's that? 10 plus X. That's 10 plus X. Why is this 10 plus X? Because you are adding this to this, right? So the final amount you're going to end up with is 10 plus X. Think of having a big bucket. You dump in X and you dump in 10. How much is in the bucket? X plus 10. So here we go, 0.28x plus 1.6. Feel free to use a calculator. Do be careful with these decimal points when you, start subtracting and stuff. A mistake that's made here sometimes is when we subtract 0.21, we don't get 0.7, do we? We get 0.07. So just watch that. I got 7.143 meters. Is that okay with everybody? Anybody have a question about that one? Okay. And then the last one says the price, I guess the price of chicken sandwiches in the cafeteria was $4.25 last year. The price is $3.75 this year. What is the percent decrease? Okay. Let's talk about that for a minute. Anybody remember? I can't remember if that was one of our book problems or not. Was percent decrease or increase one of our book problems? How do we do percent decrease or percent increase? We call that percent of change. Anybody remember how we do that? It doesn't matter whether it's increase or decrease. You take the difference and you divide it by the original. That's it. It's the difference divided by the original. You learned that back when you were freshmen. So what's the difference? Between last year's price and this year's price, the difference is? Yoo-hoo! What's the difference in the amounts? What's the difference mean?
Subtract.
Subtract. What do I get when I subtract?
4.65
I think it's just 0.5, isn't it? Isn't it just 0.5? That's the difference. And then the original, that was the first price, was 4.25. So I'll just do that division, 0.5 divided by 4.25. And I get about an 11.76%. And then I have to add the word decrease because my prices actually went down. Okay, how do you find percent of change? Difference divided by original. That's it. It's that easy. If they went up, it's an increase. If they went down, it's a decrease, but you find it exactly the same way. Well, how's that for perfect timing? All right. So tomorrow,